In this video, you're going to be learning about factoring by grouping. This can be one of the most confusing parts of factoring quadratics, and I'll be working with the CUDA software worksheet handed out in class. And this work, although the worksheet starts out with number 1, I'm actually going to start off with number 7. And what you're working with is it's something, it looks longer than it should. You're used to working with trinomials. You worked with difference of two squares and perfect squares. But in this case, you have 4 terms rather than the customary 2 or 3. And what you will be looking for is groups of binomials on this page. Now there are some that are going to be a trinomial, which means the first 3 in most cases plus an additional 4th that will factor out. But for the purposes of this lesson, we're going to be working with groups of binomials. So I want you to focus on the first 2 and the last 2 terms. And I want you to find a common monomial in those pairs. All right, so I'll model 7, and then we'll go back and go through some of the twists and turns that this worksheet contains in the, I guess, 28 problems that there are. And you can take your time working with this, and when you run into questions, feel free to ask me for help. Also, when you're using the video, right now I'd like you to just watch me work through 7 and listen to the description of what's happening. But then stop the video, try it yourself, see if you can come up with the same answer. And if you don't, rewind the video, go back and watch that again. Just watch it modeled, and eventually you will learn how to work with these problems. All right, on number 7. First off, I want you to find the greatest common monomial. So you're still doing the factor first philosophy here. Factor first. Between these first 2 terms, between 25 and 5, there's a 5 in common. And v cubed versus v squared, I can factor a v squared out. And I'm just working with these first 2. So 5v squared taken out of 25v cubed leaves me with 5v. And 5v squared divided by itself is 1. Now moving on to the second pair, between 30 and 6, my greatest common monomial is a 6. When I take 6 out of 30v, it leaves me with 5v, and 6 divided by itself is 1. Now here's how factor by grouping works. Typically, you're going to have the exact same thing here and here. And that's a good thing. That's what you want. If you don't get that, the odds are you've probably done something wrong along the way. I can take that 5v plus 1 and right against it put the leftovers. So here's what's the same between what you have factored out in the second step. And the leftovers follow it. Now the order of these parentheses don't matter. I can put 5v squared plus 6 in front of 5v plus 1. It won't make any difference. But this is your answer in the simplest version of factoring by grouping. Now why does this work? It's important to try to figure out why things work. If you look up in this step, what you see is a complex distribution property problem. I have 5v squared multiplying by 5v plus 1. And I have 6 multiplying by 5v plus 1. In summary, that's what's actually happening right here. This is distribution. If I take that 5v squared plus 6 and I put it first, you can look at this either way, but I'll try to get this to make sense. If you did the FOIL method, you would do 5v squared times 5v, which is this step. Then you would do 5v squared times 1, which is this step. Then you would do 6 times 5v, which is this step. And you would do 6 times 1, which is this step. If you did each of those separately, 5v squared times 5v would give you 25v cubed. 5v squared times 1 gives you 5v squared. 6 times 5v gives you 30v. And 6 times 1 gives you 6. So what you're writing is an equivalent expression to the original 4 terms given, just in its fully factored form. And why you have to know how to do this is to be able to eventually turn this into an equation that you can solve. Because we eventually do want to know what that v is going to equal once we turn it to an equation. Alright, so that's not going to digest fully the first time you see it, or first couple of times you see it. But there's the most simple example that you're going to run into. So 7 is one of your easy ones. Let's look back at, I don't know if I'm ready for 1 yet. Let's look at number 2. Number 2 is actually a little bit simpler to understand than number 1, and I'll explain why when I go back to it. Alright, number 2. I already told you you're looking for binomials. For the most part, until I tell you otherwise, you're just doing this essentially. I want you to look at the first pair first, these two, and find a common factor. So it's all about common factors. Between 12p to the third and 21p to the second, I know I can factor out p to the second. And what's the biggest common factor of 12 and 21? That's going to be 3. So go ahead and factor that out quickly. You got 4p minus 7. Now if you need a little more time with that, make sure you understand how to fully factor the greatest common monomial out. Alright, now my second term, right here. I have a 28 and a 49. So 7 is my greatest common monomial. So I'm going to put plus, because that's a little plus sign right there, 7. Now 28p divided by 7 is 4p. Negative 49 divided by positive 7 is a plus, that is incorrect. I meant to put a minus sign. That's what it should be. Minus 7. These two things should be the same. They are. So 4p minus 7 is one of my terms in parentheses. That's what is the same. And what is left? And what's left is 3p squared plus 7. That's your answer. Stop right there. This is fully factored. It's a fully factored version of this original expression. Now let's try that one more time with number 3. Number 3, we're going to look at our two pairs. Now this one's got a little twist down here with this negative sign. When you see a negative sign here, I want you to use some caution when it comes to that. It's a little bit trickier. But let's take it one at a time. You got the first two, the greatest common monomial is 2x to the second power. Factoring that out, you get 6x plus 1. Now you see that minus sign. We're going to put a minus here. The greatest common monomial between 5 and 30 is 5. Now here's where it gets a little bit tricky. Just be careful. Use caution with this. 30x divided by 5 is 6x. And you notice that negative 5 times 6x gives me negative 30x. Now what I put here after 6x can trick people up. Negative 5 divided by negative 5 is a positive 1. To make sure you've handled your sign correctly, when you distribute negative 5 out to the positive 1, you should get negative 5. You should get the original number that is at the end of this expression up here. Plus, I have the same thing on both here. If you have the signs different, the odds are you've made a mistake. So I'm going to take what's the same and put it in one set of parentheses. And next to those parentheses, I'm going to put what's left over, which is 2x squared minus 5. Now, I've not addressed it yet, but you also have to be careful that you can't further factor what's in parentheses. 6x and 1 cannot be further factored. Neither can 2x squared minus 5. So we're safe to call it quits on number 3. Alright, now let me return to number 1. Why is number 1 different? Let me just get us started first. You already know what we're looking at. The greatest common factor of these first two is 8, r to the second. In parentheses, I would have an r minus 8. And now look at your second pair here. Plus r minus 8. I could put those in parentheses, kind of get that same and leftovers idea here. I have r minus 8 that's the same on the 2. And I can go ahead and put r minus 8 like I did in my other examples. And I have an 8r squared here. And I have a plus sign. But what goes here? Well, the number that's not written is a 1. And I put a 1 there as kind of a placeholder. So 1 times r will give you that r. 1 times negative 8 will give you that negative 8. So that one's just a little bit different. It's easier to see a couple of other examples before you move into this 1 as a placeholder. Just be careful here. A lot of people leave that out and just have r minus 8 times 8r squared, which will not get you your previous step. When I distribute all of this out, I eventually should get this. All right, let's look into kind of a further step when it comes to this. Number 6. Now I'm going to just continue modeling, showing you greatest common factors in my pairs, and then explain what this don't stop without checking for further factoring possibilities means. In the first two monomials, I have k squared that I can take out, and also 21. I know that 21 times 4 is 84. So that's going to be k minus 4. And if you need me to slow down, you have control over my speed. So pause me anytime you need to pause me to work ahead or to catch up. In my second set, my greatest common factor is a 15, leaving me with k minus 4. These are the same. That should happen. So k minus 4. And now what's left? The k minus 4s are the same, so I'm going to put that one time. Remember, it's distribution. Now, what is it distributing to? It's distributing both to a 21 k to the second, and it's distributing to a 15, a positive 15. But I'm not done yet. I have to check out further factoring possibilities. There's nothing I can do with k minus 4, but you notice that 21 and 15 both have a common factor of 3. So in my next step, I can take a 3 out of that second set of parentheses, leaving me with 7k squared plus 5. That's 3 times 7 is 21. 3 times 5 is 15. But I never put this in the middle like this. Nope. What I have to do with this is make that 3 go out in front, and then put my k minus 4, and then put 7k squared plus 5. Never embed your constant in the middle of something. But this is my final answer. I could go a little further with that problem than I had the last examples. All right, I've got 4 more to show you after that. And there's a couple of other tricks, but this is like a puzzle. You have to figure out all these little aspects and really be keenly aware of what you're doing in your math. All right, number 9 on the front of this page. All right, 96 and 84. Both of those have a common factor of 12. So I'm looking at just these first 2 right now. Also, I don't want to forget my end of the second. So 12 times 8 gives me 96. Don't forget your n. 12 times 7 gives me 84. My n squared is already covered. I'm going to assume this second pair will leave me with 8n minus 7. Use that as a hint. Let me get this out of the way. I can use this as a hint for what should come over here. So if you get into unfamiliar numbers like 112 and 98, and you're not really sure how you get to it, use the 8 into 112 or use the 7 into 98. As you get more familiar with how the problems work, you can do that better. But if I want to do, just quickly, the 7 into the 98 to see how that works, if I do 98 divided by 7, I get 14. I bet I'm going to factor out a 14. So 14 times 7 is 98. Is 14 times 8 112? 8 times 4 is 32. 8 plus 3 is 11, so that checks out. So I know I'm okay. So I can write 8n minus 7 as what's the same. What's different? 12n squared plus 14. Now, again, don't stop without checking for further factoring possibilities. 8 and 7, I'm done. But 12 and 14 are both even, meaning I could factor a 2 out. To save myself work, I'm just going to pull a 2 out way up here, copy down my 8n minus 7, and then just half both of these terms. 6n squared plus 7, and I'm done. If I'd pulled the 2 out, or let's say I've had these two parentheses reversed, it would probably look smoother to you, and you could see how that 2 would distribute to both of these terms to create this binomial. The 2, if you used it over here, would be gone. You wouldn't also use it here. All right, now let's add some variables in. Notice I have x, w, x, k squared, y, w, y, k squared. It looks like a big mess. But still, if you just know where to look, a lot of algebra is just where to look. We split it up into binomials. Also, I want you to be careful because you do have a subtraction symbol between your two binomials. All right, let me get rid of my marks here so I can see things nice and clearly. And I want the common binomial of 56 and 49. That's going to be a 7. Also note that I have x and x. So I'm going to pull that too. So if I take 56xw and I divide it by 7x, I get 8w. 49 divided by 7 is 7, and don't forget that k squared is there. So you just have some added variables in there. Now it's going to be a subtraction problem. What's the biggest thing in 24 and 21? That's going to be 3. And I have a y in both of these terms also. So I'm going to take a y out. And that leaves me with 8w plus, and you could probably guess, 7k to the second. Now let's just check this to make sure I'm okay. Negative 3y times 8w would be negative 24 YW. Negative 3y times 7k to the second would be negative 21 yk to the second. Check your terms, check your signs. Everything looks good. All right, so I know that I'm correct. This was just my check. It's easy to get signs backwards, so you have to pause and just make sure you're on the right track. Now I have the same thing in common again, so 8w plus 7k to the second will be my first set of parentheses. And that's what's the same in both of these steps. And what's left over? Well, the 7x and a minus 3y. Can I factor either of those further? No, I can't. You can run into situations where you might have a difference of two squares or a perfect square that you could continue to factor, but in this case, we don't have that problem. So you're finished. Okay, on the back side, number 17. See, this one has a bunch of stuff, but we're still just going to start out looking at this first binomial first. What's in common between 3 and 12? 3. You notice they both have x squared. So let's get that out of there. And that's going to be 4u plus, if I pull the 3x squared out, all I'm left with is v. In my second binomial, between 28 and 7, I'm going to have a 7. You notice I also have a y in common. So I'm left with 4u plus, and if I pull 7y out, v. It's the same thing. Put a little tail on my u so you can tell u's and v's apart. I have the same thing in those two parentheses. So 4u plus v. And in my second set, I'm going to have 3x squared plus 7y. I can't factor either of those further, so at that point I know I'm done. Alright, where it gets the trickiest is when you have to reorder things. Number 27 is a good example of that. This is the very last row of your worksheet on the back. And if you go in looking for binomials, you have 28 and you have 25. Well, nothing goes into 28 and 25. You have x, y. This is a constant. Over here you have an x, you have a y. So what you're looking for, you're trying to reorder these in a way that you can pull something out and have the same result. You can get those parentheses that are the same in your two binomials. And this takes practice more than anything else. This is very much a puzzle. And what I'm looking at, my first thought process is I have y's in common. My highlighter out here. I have y's in common here. And I have x's in common here. So what I need is some way to reorder all of this to where when I pull something out, I'm left with identical parentheses. So I'm going to try something. I'm going to put the yellows together. I want these two together. Let's put 28xy plus 20y. And I'm thinking ahead. Think of it like a game of chess, to where if I pulled out a y, and the greatest common factor, I guess, would be a 4 in this case, then I would get 7x, and I would get a 5. All right, so I'm going to be left with an x. So when it comes to these final two terms that I still need to order, if I want a 7x in front of a constant, I'm going to put the 35x next, and I'm going to put the 25 at the end. So let me write down what I was just saying. If I pull out a 4y out of this, I'm left with 7x plus 5. Now I've set myself up to be able to do the exact same thing here by pulling out a 5. So 35x plus 25, if I factor 5 out, leaves me with 7x plus 5. All right, now just do what you've just done. Seems like a dozen times. 7x plus 5 is in common. That's the same. What is that being distributed to? It's being distributed to 4y plus 5. And that can't be taken further, so you're finished there. When you have to reorder, it gets a little trickier. And you're going to have to do that on everything from, let's see, 24 through 28. 24 is kind of a tricky problem also. Let me just write that in. I don't think we covered that. 24 is the first one you'll encounter. I'll just write this one out. 24 gives you 4xy plus 6 minus x minus 24y. So it's another one where it's just scrambled. With the highlighter, I've got an x here and here. And I've got a y here and here. There's more than one way of doing these problems also, so what makes it a little bit trickier. But my thought process here is I'm going to work with that 4xy first. And I want to pull something out of that to where I'm left with the same thing on both terms. So I think I'm going to take my x's first. Because I can pull out an x, I'm left with 4y minus 1. Now that's just out of these two terms. I just handled this one and this one. I'm still left with negative 24y and positive 6. So what do you do with that? What is a common factor of 6 and 24? I hope you're thinking 6 is the GCF. Greatest common factor of 6. So what order do those need to be in order to match a 4y minus 1 once the GCF is pulled out? I'm going to leave that for you to kind of figure out. If you still have further questions about those, that would make sense. But just see what you can come up with before you rely on me for help. Go back through the last example, number 27. and just watch it, see how it was reordered, and maybe try putting it in a different order to see if you get the same result or whether it turns things around on you. Again, know that factor by grouping is a complicated thing. It's not hard, it's just complex. You have a lot of things you're looking at. You have to have all your signs right, all your integers right, handle negative signs. Watch out for those little signs I made that look like caution marks. You're going to lose a lot of negative signs. So it starts out, don't forget your 1 here, as we did in problem 1. We put this in there. You don't have to do that much in this worksheet. When it comes to looking at the pairs, most of them all the way through number 23, you can just do straight. You don't have to reorder anything. It's just the last 5 where you have to worry about the order. So be looking for what's in common. If it's not in common, you've probably made a mistake. So on all of these, this 5e plus 1 and this 5e plus 1, you should have that pattern. If not, look for a mistake somewhere, especially in a sign. So for number 2, you have 4p minus 7 repeated. For number 3, you have 6x plus 1 repeated. So look for that pattern. Remember, in the end, don't stop without checking for further factoring possibilities. That is something that's going to be an issue on of course number 6. That's the example shown. You're also going to do that for number 8 and number 9. You just quickly glance over my work to see if there's any others you have to go further with. And I don't think so. So just those 3. Keep your heads up for further factoring possibilities. All right. Well, I'll let you start your work. And of course, as always, when you have questions, feel free to ask in class at any opportunity.